We're going to start a 4A with the warm-up. It's a little bit difficult to see here. It says match the vocabulary words with the definition or the picture. Let's see if I can make this darker. Oh, let me go back. All right, so I'm going to write these in since it's kind of difficult to see. The words are: number 1 is the median. Number 2 is the altitude. So this is median. Which one is the altitude? Which one is an equilateral triangle? And which one is equiangular? Okay, so match them up. All right, median would be number 1. The median starts at an angle, goes to the middle of the opposite side, which is marked with these points right, or these lines right here, which shows it's the middle. The altitude is the height, which makes a 90-degree angle. The line that starts at an angle goes to the other side at a 90-degree angle. Equilateral would be all 3 sides are the same. It's kind of cut off here. This has 2 marks. This has 1 mark. So equilateral would be this one right here. And equiangular, all the angles are the same. Alright, so 4.8 is proving special triangle conjectures. We're going to use technology for this next conjecture. Let's see, I'll click on the investigation. We'll go to that. While we wait for that to load, I'm actually, okay. But if not, we'll skip right to the main concept of today. So I'm going to come back to that if it's here. But it just asks which is longer, the angle bisector CE or the altitude CD. So we can look at these numbers right here. CE is the angle bisector, cuts the angle in half, and that's 10.57. CD is the altitude. It makes a 90-degree angle with the opposite side. So here's CD. And so in this triangle, CE, the angle bisector, is longer. Is it true if you change the shape of the triangle? And you'll find that when it changes the shape, this will also change. So this is not always. So let me see if mine has loaded. Okay, so we take a look at this. I can change the shape of the triangle, I think, by dragging it. Look at CD and CE. So before, CE was bigger, but I can change it. So C, let's see if I can make it so it works. All right, there they're exactly the same. Okay, so you can see that they change. Which is longer, the angle bisector CE or the median CF? So here the median is longer. Is this true for all triangles? No. Press the button to make a triangle isosceles. What is the relationship between all 3 of these measurements? So let's go to our make isosceles triangle. You'll see that all the measurements are the same. Drag the vertex to change the triangle and then press the button to make it isosceles again. Did the relationship that you noticed in step 3 hold true? Okay, so let's try that. So change it, make isosceles. Yep, and they're all the same again. Yes, this is true. So formulate the vertex angle bisector conjecture. In an isosceles triangle, the bisector of the vertex angle is also the altitude and the median. And this is true in an isosceles triangle. So it means that these 3 will be the same measurements if the triangle is isosceles. So let's practice using this conjecture. Let me go back here. Okay, so practice. All right, so again, here's the vertex angle bisector conjecture, bigger. So again, if it's an isosceles triangle, 2 sides are the same, then this line coming down will be not only the bisector of the vertex, so it's going to cut the angle in half, it's also the median, which means that these 2 are the same, and it's going to be the altitude, which means that is 90. Okay, so practice problems. So applying this, let's say CD is a median. If it's a median, then these two are the same. The perimeter is 60, and AC equals 22. What is AD? So these would also be 22. These would be the same. And we know it adds to 60, so we're going to add 22 plus 22 plus 2x here equals 60 degrees, and we'll solve. So we have 44 plus 2x equals 60. Subtract 44 from each side. So we get 2x equals, I get a 6 here, this is a 5, 16 divided by 2, so AD equals 8. Each of these are 8. Let's say CD is an angle bisector. Okay, so let me erase this right here. Alright, so let's say CD is an angle bisector, and the measure of angle A is 54 degrees. Well, if that's 54, this is 54, it's isosceles. So this angle will be 180 minus 54 minus 54. And then ACD is half the angle, so we'll divide it by 2. So that would give us 72 degrees if you to work this out. And the last one, if CD is an altitude, so again I'm going to mark what we have. CD is an altitude, so these are 90. The perimeter is 42. ACD is 38. So this is also 38. And AD equals 8, so this is also 8. Find the measure of angle B. CB, this line right here. Okay, so first let's start with the angle. 38 plus 38, we'll add that together. 16, 3, 6, 76. Then for the whole triangle, we're going to take 180 minus 76. But these two angles are the same. So we'll divide that in half, and we'll get the answer. So measure of angle B is 54 degrees. CB, okay, so these two sides are the same. And this length is 16, so we have 2x plus 16 if we add all the sides. That equals 42. Solve for x, so subtract 16 from each side first. Divide by 2. So we get 6. This is a 3, so we get 26. Divide by 2. So x equals 13. So this side is 13. Okay, so you'd have to know how to set up the equations, you have to know what's equal, and so on to solve. If a triangle is equilateral, which means all three sides are the same, is it equiangular? Paragraph proof using the isosceles triangle conjecture. All right, well, if it's isosceles, these two are the same. And if it's equilateral, these three sides are the same. So here's our paragraph proof. AB is equal or congruent to AC, and that's equal to CB. And that's given because it's equilateral. All three sides are the same. If AB equals AC, so if these two sides, AB and AC, are the same, then the measure of angle B is the same as or congruent to the measure of angle C. Okay, that's the definition of an isosceles triangle. Isosceles triangle theorem. Alright, likewise, if AB equals BC, those two are the same, then the two base angles are the same, so these are the same. Angle A is congruent to the measure of angle C. Alright, then we can say if the measure of angle A is congruent to the measure of angle C from right here, and the measure of angle B is equal to the measure of angle C. So they both equal angle C, so they must equal each other. Then the measure of angle A is congruent to the measure of angle B. So if a triangle is equilateral, then it is equiangular. All the angles are the same. equiangular. Okay, so if it's equilateral, it's equiangular. Okay, we can write it the other way around too. Is the converse true? All right, so the converse of that would be, if it is equiangular, then it is equilateral. Oops. If a triangle is equiangular, then it is equilateral. That is true. And why is it true? Well, think about it. If these angles are the same, from the isosceles triangle theorem, we know that the base angles are the same, the sides are the same. And if these base angles are the same, the sides are the same. So the equilateral, equiangular triangle conjecture. Every equilateral triangle is equiangular. And conversely, every equiangular triangle is equilateral. Okay. So we'll do one of the homework problems together. Here it is. It's biconditional. A biconditional conjecture is when both the statement and its converse are true. So this is a biconditional conjecture. Both the conditional and the converse are true. Okay. And the last one, number 16 on your assignment. Complete the flowchart for conjecture A. Conjecture A. The bisector of the vertex angle in an isosceles triangle divides the isosceles triangle into two congruent triangles. Let's draw on the given. ABC is isosceles, that's drawn in. So if isosceles AC is congruent to BC, that's drawn in. And CD is the angle bisector of angle C. So that means these are equal. They share a side, so we can mark that. Okay. So let's go to the flowchart proof. CD is the bisector of angle C. That's given. We have to put something here. Definition of an angle bisector. So this one right here. Angle ACB. This angle, angle 1. Actually, it's ACD. I wrote that wrong. So angle 1 is congruent to angle BCD because that's the definition of a bisector. ABC is isosceles. That was given. And here, CD is congruent to itself. That's the same segment. So here we have side, angle, side. So by side, angle, side, the triangles are congruent. So here's your assignment for 4-8. It's kind of hard to read, so I'll rewrite it. 4-8, page 245, number 1 through 6.